Example 3.6, finding the slope of a tangent line. So consider the function f of x, which is 3 times x minus 5 squared plus 2x. Find the slope of the tangent line to f of x at the point x is equal to 9. All right, let's give ourselves a rough sketch of what the function is going to look like so we can make sense of this. So it's a second degree polynomial. I know it's going to give me a parabola. It has a leading coefficient of 3. Right? If you were to multiply all this out, you'd get 3x squared plus some other stuff, right? Something involving x, maybe a constant. But either way, your function is going to look something like this. And there's a point over here when x is equal to 9. I'm asking for the slope of the tangent line. Right, I want to find the slope of the function at the point 9. So the slope of the tangent line is the limit as h goes to 0 of the difference quotient, f at 9 plus h minus f at 9 over h. Right, I'm taking slopes of secant lines and using the limit to turn those secant lines into a tangent line. Okay, so let's go through this. We're going to take the limit at the very end, so you're really just going to copy down that limit sign until you're actually ready to take the limit. What is the function value at 9 plus h? So let's work on f at 9 plus h. If I plug 9 plus h into f of x, that will be 3 times 9 plus h minus 5 squared plus 2 times 9 plus h. All right, I then subtract f at 9. So what is my function value at 9? I'm going to wrap this in parentheses to make sure that I distribute that negative sign because I want to subtract the entire value of f of 9. So what is f at 9? That is 3 times 9 minus 5 squared plus 2 times 9. Right, the value of that bracket is f at 9. So then you divide by h. All right, limit as h is going to get sent to 0. So you can't plug in h is equal to 0 just yet and use direct substitution because you're going to get a 0 in your denominator. And then that red term right there, if h is equal to 0, that just becomes this green term right there. So therefore you have 0 over 0. You have that indeterminate form. So we need to do some algebra before we actually take the limit. So let's clean this up a little bit. The box in red, 9 plus h minus 5. Well, the order of operations says that I can add the 9 and the minus 5 together. This just gives me a 3 times 9 minus 5 is 4. So 4 plus h squared. And then let's go ahead and distribute that 2 to the 9. You get an 18. And to the h, you get a 2h. And then we'll subtract. I'm not ready to distribute that negative sign just yet, so I'm still going to open up some brackets. Our order of operations tells us what is 9 minus 5? That's 4. Once you have a 4 inside that parentheses and you square it, you get a 16. And if you multiply that 16 by 3, you get a 48. So 48 right there, plus a 2 times 9, that's an 18. All sitting on top of h. So I still don't see the cancellation that I'm looking for. Let's keep playing around with it. So when you have 4 plus h squared, and you send the 3 through, you're going to get, what is that? 4 times 4 is 16 times the 3 gives you that 48. you'll have plus 4h and then another plus 4h, so plus 8h, and then 8 times the 3 results in 24. So plus 24h. And then you have an h squared times the 3, so plus 3h squared. You still got the plus 18, the 2h, and then 48 plus 18, what are we going to get there? 48 plus 18, 66. So I'm going to subtract off 66. All right, let's simplify. 48 plus 18, well, that gives you a 66. So then minus 66, your constants are gone. How many h's do we have? You've got 24 of them, plus another 2 of them. You've got 26 h's. And you have that plus 3h squared there, all sitting on top of an h. And that's where our cancellation comes from. You have an h present in all of your numerator terms. You can pull that out. So if you pull an h away from the numerator, you're left with a 26 plus a 3h over the h. Those h's cancel. And after you cancel, you now can directly substitute. Right? When you send h to 0, this just becomes 26. So the slope of this line right there, the tangent line, has a slope of 26 units, or rather 26 y units per x unit, right? So for every one movement I go up, or rather every one movement I go over, I go up 26 units.